Okay, today we're going to do angled projectiles, and just like horizontal projectiles, they're going to work fairly similar, and that you have to make sure you separate the horizontal and the vertical motion, keep it separate, where time is the only thing that's the same between both, and the questions will be very similar to what we already did. The only thing you want to be careful of is because the ball is going to be going upwards at an angle, it's going to go up, it's going to hit the peak, and then it's going to fall back down. So we have to be kind of aware of what happens when we did the up and down motion as well. So let's kind of look at what happens to this ball as it goes through different phases of the pathway. So let's suppose the ball is going to start at the ground level. Let's suppose it's going to move upwards. We're going to hit it at the peak. It's going to be coming downwards, and then it's going to be back at the ground level once again. So just like with horizontal motion, when we kick this ball, it's going to have some sort of horizontal speed. So let's suppose it was 8 again. Because it's horizontally, we had nothing slowing this thing down other than wind resistance, which we'll ignore. So that means that horizontal speed of 8 is going to be the exact same all the way through the entire path. The vertical motion now, though, is going to be a little bit different. So when we kick the ball, let's suppose we initially kick it upwards at a speed of 10. As it goes up, gravity is going to slow that thing down, so maybe part way through it's going to be less, and then by the time it gets to the top, its vertical motion is going to be 0, right? It's going to stop for a split second at the top, and then it's going to start to speed back up again, going downwards. So if it started at 10 going up, it's going to finish at 10 going down, and when it hits the peak, it's going to have a speed of 0. So that's the biggest difference between these kind of projectiles and the other, but you just got to remember that you got to deal with your horizontal and your vertical stuff separately. Keep them separately so that you don't mix them up. So let's do an example with this kind of question. So let's suppose we kick a soccer ball, and we're going to kick it up at an angle of 40 degrees at a velocity of 20 meters per second. Okay, so if that was our initial setup, 20 meters per second at 40 degrees, what we got to be careful now is what is our vertical and horizontal information. The 20 meters per second is the angled speed, that's the actual speed the ball is going, but we want to be able to deal with horizontal and vertical motion separately. So the first thing you're going to have to do with these is calculate those two side vectors like we did previously with vectors. So you're going to find that bottom side, the adjacent side, so we'd have cosine of 40 will equal x over 20. So go cos 40 times 20, and that'll give us an answer of 15.3 meters per second. Okay, do the same thing for the vertical side, except we'll use sine. So sine 40 will be the y over 20, cross multiply those, and we'll get an answer of 12.9. Okay, so we have our initial speed of 20. Really, the 20 we're never going to use. The only thing we're going to use the 20 for is to help us figure out those horizontal and vertical components. So now that we have that, remember that's going to be the information we're using with. So let me go back to the previous page. So in this case, our horizontal speed of 12.9 stays the same throughout the whole thing, and our vertical speed of, our horizontal speed of 15.3 stays the same all the way through, and our vertical speed of 12.9 is actually going to change. So we'll have 12.9 to start with, then it's going to slow down until it gets to the peak. Remember, the peak, it'll be 0, and then it'll speed back up again until it hits the ground, going 12.9 downwards. So that's the first step, is you got to get those two vectors figured out. So let's suppose now our first question is what is the maximum height? So let's suppose the question was, how high will the ball go? So if we want to know how high that ball is going to go, we're going to have to think in vertical, right? Height is vertical, so we want to use our vertical information again. So we'll have initial velocity is 12.9, we just figured that out. We know our final velocity when it gets to the peak is going to be 0, right? It stops when it gets to that maximum height. We know our acceleration is the only thing that's slowing that thing down. And that's it. We can now solve for our vertical distance. Okay, so that's the first step, is get that distance. So the right formula will be VF squared equals VI squared plus 2AD. And we're going to plug everything in, so VF squared is 0, VI squared will be 12.9, 2 times negative 9.81 times D. So we'll go 12.9 squared, and then we'll divide by 2 times 9.81. So when you rearrange that and solve it, you should get an answer of 8.4 meters. So that means we know the vertical height. We know that it's going to go up 8.4 meters. Let's suppose the next question, just like we did with the other projectiles, quite often the next question is going to be, how long does it take? So how long is the ball in the air? Okay, so just like we did when we did cliff questions, we want to make sure we're thinking vertically once again, right? We don't care that the ball is going up at an angle like that. Really, the time it's going to take would be the exact same if it just went straight up and then turned around and came straight back down. So we're going to solve these questions just like we did before. We're going to use vertical information, so we still have our VI of 12.9. We still have our acceleration. Okay, we now have a distance we could use. But we also know that at the peak it's going to be a velocity of 0, so we could just go from ground to peak, figure out how long that took, and then times it by 2. Or we can also use final velocity of negative 12.9. We know it's going to go up at 12.9, come back down at 12.9, and that could help us solve for time. So you got a few different options for this one, but let's do it this way. So we have our 12.9 going up and down. So we can calculate it that way. So let's do it that way. So the formula we would want to use is our VF minus VI over T. So we'd have negative 9.81 will equal negative 12.9 minus 12.9 over time. So rearrange that, so we'd get negative 25.8 divided by negative 9.81, and that'll give us a time of 2.6 seconds. Okay, so like I said, you could either have done that, or you could have went from initial point of 12.9 to a final velocity of 0, and then solve it for time, but that would only be from the time from the ground to the peak, and you'd have to double it to get back down again. Or the other option is you could have used the answer from part A where we calculated the distance. So you'd had distance, initial velocity, acceleration. You could have solved it for time that way. All three methods would give you the exact same answer. It doesn't really matter which one you pick. Okay, let's suppose our next question now is, how far away does it go? Like, what's the range of the ball? When you kick the soccer ball, quite often we know how far you can actually kick it. So let's solve for horizontal distance. Okay, so we know that it's going to travel in that path. Okay, we want, basically what we're looking for is what is that distance from start to finish. Okay, just like we did before, the horizontal information is usually a lot easier because of the constant velocity. We know that its velocity was 15.3. We calculated that in the first step. Right, and we go back to that diagram. So we calculated 15.3 meters per second. So we know that's our velocity, and we also just calculated our time being 2.6 seconds. So now it's pretty easy to get the distance. So our distance will be velocity times time. So we'd have 15.3 times 2.6, and that gives us an answer of 40 meters. So we know that the ball traveled 40 meters horizontally. And that's pretty much it. Those are the kinds of questions you'd be expected to answer. We could go one step further. Let's suppose, let's kind of go back to our original diagram. So our ball was going at 20 at an angle of 40 degrees, We know that it's going to come back down at the exact same, so it's still going to be going 20, but it'll be downwards at 40 degrees this time. So the only thing that really changes is our direction. So originally, if our direction was east 40 north, it's now going to be south 40 east. It'll just be flipped around. And in terms of our vectors, the same thing will happen as well. So we had calculated that our vertical was 12.9. We know that it's going to be going downwards at 12.9. Okay. We also calculated our horizontal being 15.3, and that was constant, so it's still going to be going 15.3 when it lands. So in this case, we don't have to worry about our velocities too much because it's going to start and end exactly the same way, just directions change. The only kind of questions with this that people tend to have trouble with is when we combine the two together. So let's suppose we have a ball at the top of a cliff and we're going to launch it up at an angle and the ball is going to travel like that. So we basically have sort of a combination between a cliff question and an angled question. Okay, so let's just do one to start with here to make sure you're clear what I'm saying. So let's suppose we launch it at 30 degrees and it was moving at 10 meters per second. So to do these questions, you have to basically break it up into two. You have to be able to go from the peak, or from the initial to the peak, use that information, and then from there, you can go from there to the ground. So you can break it up into two. What some people like to do is they try to break it up so that you have a normal projectile and angled projectile for the top part, until they get to cliff height, and then from there go downwards. But I recommend not doing that because that means then when it leaves that height, it's going to be going downwards at an angle. So due to the angled part of it, I think it makes it more difficult. So you're usually better off to go just to the peak. You could calculate time, distance, anything like that. So let's do that. Let's calculate how much time it would take to get to the peak. So then for this kind of question, just like we did before, we're going to have to take that 10 and break it into its vectors, 10 at 30 degrees. So we'd have to go sine 30 times 10, that would give us 5, and we'd have to go cos 30 times 10, and that should give us 8.6, I think. So cos 30 times 10, yeah, 8.6, or we round it off, it'd be 8.7. So just like we did before, you got to make sure you get your vectors calculated because that's the numbers you actually want to use. So now we could actually calculate the time it takes to get to the peak. So just like before, we have an initial velocity of 5. We've got our acceleration. We know that at the peak its final velocity will be 0. So let's solve it for time. So using this information, we don't have d. So we could use acceleration equals Vf minus Vi over t. So our time would be 0 minus 9.81. 0 minus 5. Right? Final is 0, initial is 5, so 0 minus 5 divided by our acceleration 9.81. So we'd have a time of about a half a second, so 0.5 seconds. Okay. We could also calculate that height, right? We could use the same information to calculate what is that height above the cliff that it would travel. And quite often in these questions they'll give you the height of the cliff, so we could calculate that maximum height fairly easily. The only other part of the question that quite often you want to do is you want to break it to the peak. So in this case we found the time it took to get to that peak. We could also now calculate the time it's going to take to go from the peak down to the ground. So once again, we want to calculate time, but now our initial velocity at the peak is 0. Once it gets to the peak, it stops. Our final velocity we don't know. Our acceleration we do know. It's still 9.81. So you can see for this question, we would actually need the distance it's going to fall as well. Okay, so back to this question, we would actually have to figure out that maximum height. So let's do that quick. So our distance would be, we've got every bit of information we need. Let's just do VIT plus 1/2 AT squared. You could use whichever formula you want, but let's stick with this. So our distance, our VI was 5, our time was 0.5, plus 1/2 times negative 9.81 times 0.5 squared. Okay, so we could calculate all of that. So 5 times 0.5 plus 0.5 times 9.81 times 0.5 squared. We get an answer of 3.72. So our distance that it went upwards is 3.72. Okay, we don't have to worry about the, oh, sorry, I messed up on that one. Let me just double check that again. So we'd have 0.5 times negative 9.81, I forgot the negative, times 0.5 squared, and then add that to 5 times 0.5, so I get an answer of positive 1.27, or 1.3. So that means we went up 1.3 meters off the top of the cliff. So now when we go back to the question we were looking for the total time. You can see that we have a distance of 1.3 and a distance of 20 that we started. So we'd actually have a total distance that it's going to fall of 21.3 meters. So now we could calculate that time fairly easily. So let's use the distance equals VIT plus 1/2 AT squared once again. So our distance is negative 21.3, and VI was 0, so that part's gone. So we get 1/2 times negative 9.81 times our time squared again. So let's go 21.3 divided by 0.5 times 9.81, put the negatives in, we get an answer of 4.3, square root that, we get a total time now of 2.1 seconds. So if we go back to our diagram, we figured out 1.3 seconds to go from start to the peak, and now we just calculated 2.1 seconds from the peak to the ground. So our total time then is those two added together, so we'd actually have 2.6 seconds for the total trip. So we know our total time, we figured out our total distance vertically. The only thing left to do would be possibly to figure out how far horizontally did the ball go. So we can go back to this again. We'll need the horizontal speed, which we calculated was 8.7. So our velocity was 8.7, so now we can calculate our horizontal distance by just going 8.7 times that total time of 2.6. And we're done the question. And that gives us a total distance of 22.6 meters. Okay, so you can see with these kind of questions, a little bit more complicated, but always remember to break it into sort of the start to the peak, and then do from the peak down to the ground. You get two different parts. You can add the distances, you can add the times, but the rest of the question is pretty much the same. And that's all.